Hi, I want to take a look at the photoelectric effect and work an example of this with some metal. So say for some metal, we measure the stopping potential as a function of incident frequency of light. And we generate the following results here. So what's the work function of this metal? And if we happen to have light at an 8 times 10 to the 14 kilohertz frequency incident on this metal, what's going to be the kinetic energy of the electron released by that interaction? So the maximum kinetic energy from the photoelectric effect is equal to the photon energy, Planck's constant, times the frequency of the light minus the work function. Well, we can also read this off our graph. And if we take a look at this graph, going to the incident frequency of 8 times 10 to the 14 hertz, we have a graph of stopping potential versus frequency. So reading off there, it would take about 1 volt of stopping potential at 8 times 10 to the 14 hertz. So that means the electron would have 1 electron volt of kinetic energy. Now, the other way that we could look at this is we need to figure out our work function. So our work function is what happens when all of a sudden we cut off electrons being released, where there's no stopping potential needed for there to be no current. So this graph looks like it ends right at 5.5 times 10 to the 14 hertz. So at the moment where kinetic energy would be capped at 0, our photon energy, HF, equals our work function. So if I take Planck's constant, 6.626 times 10 to the negative 34 joule seconds, I multiply it by my frequency of 5.5 times 10 to the 14 hertz, I get an energy of 3.64 times 10 to the negative 19 joules. And if I divide by 1.6 times 10 to the negative 19 to convert to electron volts, that gives me a work function of 2.3 electron volts. So I could take 8 times 10 to the 14 hertz, multiply that by Planck's constant, convert that into electron volts, and I would end up getting 3.3 eV. I subtract off my work function of 2.3 eV, meaning there's 1 electron volt in the kinetic energy of the electrons released at that particular frequency of light. Thanks for watching.